Well, I was already introduced, so I'm manager of credit risk, so not exactly the type of guy who's at this type of conference, but I'm also one of the, which is much more relevant, I'm one of the leaders of Road to Cloud program in the bank, so in the area of analytics, as you probably, as you are aware. Okay, so we actually, we have lots of investment in the analytics in the recent years. We started in 2016 with very poor, let's just say, technological stack, and but we invest quite heavily in people, in technology, in everything what's connected with analytics. And at somewhere around 2020, and specifically in January, we did this kind of strategic exercise to figure out where are we at this, how we are placing ourselves in comparison to the films that we are aspired to. So, and we did this kind of like three-dimensional comparison in DevOps, data, and models. This is actually the three things that are very, very important for us in analytics. And what we realized was that we are very, very good at building the models. We can say this loudly, we can build really advanced models. That was not an issue for us, and it's not an issue right now. In terms of data, we are quite good at data integration at, let's just say, standard level. So all the data that are already in the bank, so transactional data or some simple algorithm, simple variables are actually managed quite well, but we had some issue with integration with new data, like geodata or something which comes very, very fast or is very new for us. And in terms of DevOps, well, I have to say that in January 2020, it was like, really, Houston, we have a problem, because getting a little bit deeper into this kind of what was wrong with us was actually we had quite a different technology stock between business and IT. That's very, I think that was very common for some companies. It is still as well. For example, if we build the models in Python, in R, in SAS, in whatever technology we choose, we had to rewrite it to give it to our IT guys, and they deploy the models with much hated Java or something like this, because we don't like Java in data analytics, because it's difficult and cumbersome for us to understand as a simple analytics. And in terms of DevOps, there was none, or even worse. There was like 20 teams, 20 analytical teams that doing completely different things, and they were just developing their own kind of DevOps solutions. So this was like, and we had quite a huge not invented here syndrome, I would call it. So if you wanted to talk about some kind of one way of doing things, there was like lots of discussions, and we always had this kind of, at the end of the day, let's just leave, let's just do it like we do right now. So we had, on the top of that, we have hundreds of models, hundreds of algorithms that are governing everything from underwriting to collections, to CRM, to I don't know, to talk to chatbots like to Eco. So if you combine this together, you can see why the DevOps was kind of important in our way to go. So because we figure out this kind of problems of our own, we try to first define what we should do, and we teamed up with GetInData and Google. And we came up with this kind of MLOps platform, which we actually call like our, let's just say, ML complete analytical platform, end-to-end platform that is actually used in our company right now. I'm not going to talk very much about each specific details of this platform, because probably there will be like several discussions today covering exactly the same thing. But I would like to say about a few things. First of the thing that is very important for us is that all our data are in the cloud. We don't have hybrid solution. We don't have on-prem solution. Actually, we have, but it runs as a dual right now, because we didn't move all of our, still not fully moved to the cloud in terms of all of the models. So there is still some some on-prem left, but we moved all our 500 terabytes of data and we moved it to the cloud. And we built the MLOps platform strictly on the cloud. So we didn't have like any connection with the on-prem world. The second thing is that was quite new for us, meaning the using of this infrastructure as a code thing, which is for most of you probably very obvious thing to do, but for us it was something quite new. So all elements of our platform are actually terraformed and put up as an infrastructure as a code thing. And I asked my friends, because I'm coming from data analyst side, as you may recognize, I asked them, okay, what's the one thing that is the most important thing in this kind of a platform? And they said, okay, tell something about Kedro, right? And I will try. So because we built this kind of infrastructure around cloud, and we wanted to make it like more robust for everybody, we used Kedro framework and built around it, of course, some specific connections to MLflow, to Airflow, so that each time the analyst is building the models, at the same time, all the artifacts of data, artifacts of models are written into the MLflow, and all the pipelines of the model are actually created within the Airflow. And of course, we have this kind of implement once and spread across all of the teams approach. And this was actually something, the biggest breakthrough, because as we are saying in our company, that we changed like Tower of Babel to this 4T assembly line, because for the first time, we had like common language with IT. The second thing is, which is quite important, because I told you we moved all our MLOps, all of our data to the cloud. And it's really nice to say why. As I told you before, we had quite a lot of on-prem investments. And we had like huge Hadoop stacks. We've tested several implementations of analytical, like RStudio, a huge RStudio server and things like that. But at the end of the day, we faced the same problem. When we tried to deploy the models, we had to spend lots of time with IT to actually to prepare the infrastructure, to build the secure infrastructure around our models. And of course, the obvious thing, the scalability of this kind of solution was quite low. I mean, if you know what is to go to for example, to the IT committee of the bank and ask for cash, you would know what is like to have like 10 or 20 or 30 projects on the pipeline. So this is like a nightmare for managers. And in terms of scalability, the cloud is absolutely, obviously better than anything else you have on the on-prem, because you not only can scale it up, but you can also scale it down. There are some, of course, issues with that. I maybe tell about this later on, but that's a different story. We also have and will have probably the HR issues. There are not enough machine learning engineers, data engineers, even data scientists, although on that front, I think we don't have a problem right now. And there are things like integration of the new data, as I mentioned, right? It's much more easier to put new data, whether it is streaming data, whether it is standard data, or some specific type of data like geodata, through the cloud technology, because you don't have to repeat the same things all over again with the architecture in the bank. And last but not least, something which is kind of important for us nowadays, ESG, the E part, which is the environmental part, because when you move to the cloud, you can compare your costs of electricity costs between your data center and, for example, cloud provider who is, for example, carbon neutral cloud provider. So there is a benefit, PR benefit to it. So we kind of like it. Analytics does not work without data. So along with the machine learning platform, we built a digital data platform, which is basically a data lake, which stores all the information for analytics. And maybe it's a common approach among banks, among companies, but very important for us are two factors that we wanted to achieve. First of all, we don't want to have like centralized data teams, because this is always a problem, because always there's a queue, and you always have like different teams have different priorities, and it is better to centralize infrastructure and just spread the responsibility for generating the analytical base tables, or whatever project you have in the specialized teams to the business teams. So we have like domain type teams in CRM, in risk, in frauds, in whatever domain is actually using the data. And the second thing is that we're still working on it actually, because we are quite good in data pipelines in terms of standard data. But there is still thing which I think I want to, for example, have some ideas during the conference today. How to implement this second thing is that when you're building the models and you're putting new variables into the analytical process, how to quickly deploy them. And this is, I know it sounds easy, but when you have, and as I mentioned, when you have a very, very simple variables, like, I don't know, a current account amount or whatever, something like this, it's absolutely easy. But within our models, we have models that uses, for example, 100,000 variables, very specific, some of them are coming from XML files, and they need to be calculated in the online mode. And this is something which we still haven't done. But the basic data pipelines we have, but let's just say, inventing the templates for the most complicated variables are still a challenge for us. But we are doing this. We have this time till the end of this year. And each project has to have a cool motto, and to explain, for example, to management what we would like to achieve. And we want to achieve something which I call smart analytics at scale. Because we haven't created the platform for the most proficient users. We have 25% of the people who are using the platform are really, really advanced PhD type persons. But we created the platform for all our users, for all our 100 platform users and 15 analytical teams, which are doing very different tasks. And what we want to achieve is something like a repeatable deployment of the most robust models. What I mean by robust, I mean let's just say the simplest models that are in place, machine learning models. They are like XGBoost, LightGBM, whatever models you think that is like next level after a logistic regression. And of course we don't want to challenge ChatGPT yet. So this is maybe the thing I wanted to say. But why we are doing this, like what we are stating this kind of things, because 90% of our business output from the analytics is from simple increase in quality of our models. And this most robust models like GBM, XGBoost, or some simple neural networks, or some basic deep learning models, they are giving us 5, 10%, 50% increase in the quality of the models, and each percent is specific number. I cannot say what is the number, but the number runs in millions. So this is why we want to spread the analytics as wide as possible, not to be like the domain of R&D guys. But this is all, but of course the R&D is also supported by the platform. But the main idea is to spread the analytics as wide as possible. And I want to tell you a few things we learned during the building of the platform, which were actually the first one, the dark side lessons learned. I call it because there were unexpected, let's just say, turns in our models, in our project. First of all, is absolutely cybersecurity. It will, whatever you do, it will take longer than you think. And when you think that this is longer, make it like twice times longer than you think. Then that's the biggest issue of the platform, and basically going to the cloud. And because we not only have to fulfill all the supervisory requirements, we also have to fulfill requirements of our cybersecurity and our security, which, as you probably know, in banks are just insane. So, you know, with the project, I cannot state it more. Sometimes, because we did it with GetInData with Google, we did it in agile style, and sometimes we have to really wait for the project, for the next phase of the project until we get the sign up from the cybersecurity guys. But we have a very secure platform thanks to this. So this is like the positive thing. The second thing is regulatory framework relating to data customer and to customers' data. This is not a problem because it's manageable. But what we want to say is that there are series of new regulations coming, which might really cause some damages to some. To some, let's just say, business usage of the machine learning, because it might require some right for human intervention, and this might cause some disturbance in some business usage of the ML platforms, machine learning in general. We are kind of not afraid because we always, as a bank, we have to like look on the people, and we have other rights to look into your current accounts, especially in the credit risk and fraud in AML. But for CRM, there might be some issue ahead. And the other thing is we spend quite a lot of time convincing, even if our management board, as you probably know, our management board was really convinced about going to the cloud. So much that we actually created this kind of idea of this region in Poland for Google, for Microsoft to come to Poland and create the region site. You have to convince lots of stakeholders, like from management board, from supervisory authority, from audit committees. People don't usually know what it means to have. Oh, I logged into some Zoom. Okay, I hope I can skip it somehow. Oh. Whoops. Okay, that's okay. Okay, it works. So you have to convince lots of people to use the cloud. They are not very advanced usually. For example, I got the question from one of the persons who are really on one of the tops of one of the organizations. Do we create Skynet or something like that? AI that will kill us all. So this is type of sometimes the question that you have to answer. So be aware of that if you are in a big organization. And the last one is actually kind of funny one, but also important. If you build something advanced, try to test it on the least proficient user. If you do that, then you have like this machine learning platform ready for everything. We kind of learned this the hard way. And of course, remember about the costs, because if you put somebody who is very low-level analytics. So he does something on the local computer, and he moves suddenly to the cloud where he can just plug into the really huge power. Then your cost might suddenly spike. Fortunately, within the platform, we have lots of fail-safes for that. We learned that actually from these examples, where, for example, we are switching off the servers. We use ephemeral servers for the ephemeral computing power for the most compute-intensive things. But really take care of that, because that's something which could blow your NPV of the project. And the bright side of the lesson learned, I know it's cliche, right? Because when I wrote it, I didn't believe myself, right? Because well, spend time on good platform design if you're building this machine learning platform. But remember about hiding complexity in the templates, in the frameworks, like we did with Kedro, right? So take complexity from the average or the standard users, put it into the templates. It works perfectly for us. And don't waste time on doing things in different technology. Like if it were, for example, if it works on CPU and it's effective, don't try to go into GPU because it's fun, right? I mean, you can do it, but only, of course, if there is some kind of innovation involved in this, but not just for pure joy. And we kind of thinking about this whole project as a assembly line, and I think we kind of did it. So this 4T example is that always stuck in my head for that. And last but not least, this is kind of actually something which I think why Skynet is still not in place. We actually, when we moved from the legacy on-prem solution to the cloud, and we started to test different things. And one of the things was actually using AutoML for our standard models. And the second approach was to build the model by machine learning experts with some hyperparameters tuning, with some expert knowledge. And each time, because this is the one picture, but I could show you like 20 or 30 or 100 of them, each time the approach wins. So there is still a value in employing very good data scientists. So still there is some money to be done in the market. So are we done? Of course not. We're still playing around with the platform, and we're still going forward with that, with heavy usage of GPUs in some kind of image recognition and things like that. So our analytical journey will probably never ends, because we are doing this for 15 or 17 years, and still there's something new coming each year. So that's definitely going to be. There's going to be some few nice challenges ahead. So thank you very much. I hope I didn't bore you to death with that. So.